Hello, welcome back. The current management information systems world, or jungle, is an exciting, fast-paced place, as we try to show throughout this survival guide. Thumping ERPs lumber around, confident in their role as top predators, while open-source alternatives snap at their heels, and straitjacket employees long to break free. Big data analytics and more conventional business intelligence systems strive to complement, if not replace, human decision-making. Pervasive clouds blur the firm's frontiers, riding on the back of exponential technological advances. In such a turbulent environment, what can we meaningfully say about the future? We shall basically propose three themes. 1. Management information systems will continue to evolve and grow in importance. 2. Some of the current trends are likely to continue and consolidate. And 3. Some shifts can be reasonably foreseen and some nascent or still immature approaches show great potential. Since you have invested time and effort in this Management Information Systems course, the first theme regarding the growing relevance of management information systems, even amid rapid change, is probably the most relevant. There are no signs of abatement in the importance attributed to management information systems by top management in most industries. A smoothly running, well-integrated management information systems architecture is seen as almost a prerequisite for staying in business, while mastering the new areas continues to be perceived as a source of competitive advantage. ICT and MIS-related capabilities continue to top the lists of most sought-after skills in the job market. You made the right investment. Regarding the second theme, among the current trends most likely to continue and consolidate, we will highlight the following three. Of course, this is just an educated guess. No one can be certain about the future. First, cloud-based virtualization, delocalization, and outsourcing will, in all probability, further push hardware and software resources out of the company's individual boundaries into shared, globally managed pools that can achieve higher utilization and efficiency via economies of scale. The case of offshoring is less clear-cut. Personal computers will probably become comparatively less powerful, being used mainly as access devices, with all the heavy crunching being shifted to virtual shared resources. Second, explosive growth in semi-structured data will continue, along with the sophistication of the tools available to manage and exploit it, including some mentioned below under the third theme. This super big data will transform the competitive environment in many industries. Think, for example, how the insurance industry would look like in a world of data deluge, as well as the workplace and the job market. And third, the boundaries between the management information systems of companies in the same supply chain will fade, paving the way for ever closer, seamless intercompany systems integration. Competition will increasingly take place between supply chains rather than between individual companies, and the information systems facet will reflect that. The same argument used in this course to justify the advantages of ERPs, namely better support for integrated interfunctional business processes, can be used for systems supporting increasingly integrated intercompany business processes. For example, in supply chains involving movement of physical goods, intelligent radio frequency identification labels, RFID, allow each product unit to be tracked individually throughout the supply chain. It does not make much sense to transfer all this data each time the unit crosses a company's boundary. In an ERP-like approach, it would be much neater to update a common database as the product moves from company to company along the chain. As for the third theme, shifts that can be reasonably foreseen and incipient approaches that hold significant promise, we will start by highlighting the shift in the long-held expectation of steady exponential growth in computing power per dollar. The demise, or rather the slowdown of Moore's law, admittedly often touted in the past, means that after 5 decades, we can no longer take it for granted that computing power per dollar will double every 2 years. It will continue growing for sure, only not so fast and not so steadily. Unless a fancy new technology such as quantum computing suddenly takes off, pure hardware advances will need to be complemented with progress in other areas. Examples of such potential areas would include cleverer software algorithms, the already mentioned economies of scale achieved through centralization and cloud computing, and new computing architectures, such as ad hoc chip designs specialized in particular tasks. Regarding particularly promising incipient approaches, we will mention 2: machine learning and artificial intelligence. In machine learning, the algorithm learns directly by analyzing many input cases. For example, it reviews many sample pictures of cats to learn how to recognize a cat, rather than being explicitly programmed or taught by a human to recognize cats. AlphaGo, a program that plays the ancient, extremely complex game of Go, recently bet a master player for the first time, using deep learning technology. Artificial intelligence, aimed at creating systems capable of intelligent behavior, has had many false starts, but it currently seems ripe for major breakthroughs.
And with all this artificial intelligence, machine learning and so on, how long will it be before information systems take over and we humans are no longer the apex predators in the food chain?
Well, let us hope that this is not what the future will look like. To recap, I think we can confidently expect a future marked by the continuous relevance of management information systems, the consolidation of such trends as cloud-based virtualization, big data, and ever-growing inter-company systems integration, as well as the emergence of new approaches such as machine learning. Thanks for watching. I will see you in the next video.